Electric cars are amazing, but let's be honest, they have a problem. You're stuck waiting 30, 40, sometimes 50 minutes at a charging station. Your range anxiety keeps you awake at night, and the battery in your car degrades faster than you'd like. What if I told you that all of these problems are about to be solved? What if I told you that Toyota has already found the answer? And what if I told you that this answer is coming much sooner than you think? For decades, the electric vehicle industry has been playing catch-up with a fundamental limitation. The battery technology powering every EV today is based on lithium-ion technology commercialized in the 1990s. We've made incredible improvements, but we're reaching the theoretical limits of what lithium-ion can do. That's where solid-state batteries come in. Solid-state battery technology isn't new. Scientists understood how to build these batteries since the 1970s. The real challenge has always been manufacturing at scale while keeping costs reasonable. That's where Toyota comes in. Toyota has been investing in solid-state battery research for over 3 decades, assembling one of the largest patent portfolios in the world for this technology. After decades of preparation, they're finally ready to bring this revolutionary battery to the mass market. Let's start by understanding what makes solid-state batteries fundamentally different from the lithium-ion batteries in your current phone or electric car. In a traditional lithium-ion battery, the electrolyte is a liquid. This liquid electrolyte is basically a chemical soup that allows ions to flow between the positive and negative terminals of the battery. This liquid electrolyte is flammable and volatile. It's heavy and bulky. It needs to be carefully contained because if it leaks, it can damage the battery and cause fires. The entire architecture of a lithium-ion battery is designed around managing and protecting this liquid electrolyte. Engineers have spent decades optimizing these safety systems, but the fundamental limitation remains. You're working with a flammable liquid. A solid-state battery works on the same basic principle, but instead of using a liquid electrolyte, it uses a solid material. This solid electrolyte could be made from ceramics, polymers, or other advanced materials that don't have the same volatility as liquids. The moment you replace that liquid electrolyte with a solid one, you unlock a cascade of advantages. First, a solid electrolyte is not flammable. This immediately makes the battery safer. You eliminate the risk of electrolyte leakage and associated fire hazards. Second, a solid electrolyte allows for much higher energy density. Because you don't need the same safety containment infrastructure, you can pack more energy into a smaller, lighter package. Third, solid electrolytes have better thermal stability, meaning they maintain their properties across a wider temperature range. This is huge for electric vehicles. Higher energy density means longer range. It means the same size battery can take you further down the road. In fact, Toyota's projections show that their first-generation solid-state batteries will deliver approximately 745 miles of range on a single charge. To put that in perspective, the current best-in-class electric vehicles max out at around 450 to 500 miles. We're talking about a 50% increase in range. That's not a minor improvement. That's a fundamental transformation of what electric vehicles can do. But range is only half the story. The other half is charging time. And this is where solid-state batteries get truly revolutionary. Because of the superior ionic conductivity of solid electrolytes, solid-state batteries can handle much higher current levels without degrading. This means you can charge them much faster. Toyota is targeting a charging time of just 10 minutes to go from 10% to 80% battery capacity. That's not 30 minutes. That's not 20 minutes. That's 10 minutes. That puts you back on the road almost as quickly as you would with a traditional gasoline car. Think about what this means in practical terms. You pull up to a charging station, you plug in, you grab a coffee or use the restroom. You come back, your car is charged. This changes everything about the user experience of electric vehicles. This eliminates the primary objection that millions of people have about switching to electric cars. Charging anxiety will no longer be a factor in the purchasing decision. Now, you might be wondering how Toyota is planning to bring this technology to market because, remember, we've been hearing promises about solid-state batteries for years. We've been listening to companies make grand claims about this technology for over a decade. And yet, as of right now in August 2026, there are no production solid-state battery electric vehicles on the road. So what makes Toyota different? Why should we believe that Toyota will actually deliver on these promises when so many other companies have failed to do so? The answer lies in Toyota's methodical, step-by-step approach to this transition. Toyota isn't trying to go from 0 to 100 overnight. Instead, they've charted a carefully planned roadmap that spreads the technology rollout across multiple generations of batteries spanning the next decade. This approach minimizes risk and ensures that each step is achievable with existing manufacturing capabilities and supply chain infrastructure. The first step in this roadmap is the 2026 timeline. Toyota is currently developing what they call next-generation lithium-ion batteries These aren't quite solid state yet, but they're a massive step forward from current batteries. These new lithium-ion packs will provide around 621 miles of range per charge. That's already double the current range of Toyota's own bZ4X electric SUV. Furthermore, these batteries will charge from 10% to 80% in just 20 minutes. The cost will be 20% lower than existing battery technology. This bridge technology is crucial because it keeps customers satisfied while the company perfects solid-state production processes behind the scenes. These 2026 lithium-ion batteries are scheduled to power a next-generation electric vehicle that Toyota will introduce that same year. This gives the company time to validate the manufacturing processes, work out any supply chain issues, and gather real-world data about how the batteries perform in customer hands. It's a smart move because it reduces the risk associated with bringing a completely new technology like solid-state batteries to the market. These first-generation solid-state batteries will deliver the 745-mile range figure we mentioned earlier. Charging will take approximately 10 minutes. The company has confirmed that it's sticking to this schedule and that the first solid-state battery-powered vehicles will debut in 2028. These vehicles will likely first appear on Lexus models. This makes strategic sense because Lexus buyers are early adopters willing to pay a premium for cutting-edge technology. It allows Toyota to control initial volume and manage production capacity carefully. The third phase of this roadmap extends beyond 2028. During this period, Toyota plans to introduce an even more advanced second generation of solid-state batteries. The second generation is expected to offer approximately 50% more range than the first generation batteries. That would translate into roughly 1,000 miles of range on a single charge. It would also feature even faster charging times, though Toyota hasn't released specific figures for this generation. To make all of this happen, Toyota has assembled a powerful partnership. The company has been collaborating with Idemitsu Kosen, one of Japan's largest chemical companies. Idemitsu has decades of experience working with advanced materials and chemical processes. Together, Toyota and Idemitsu have committed to jointly developing and mass-producing the solid-state batteries that will power Toyota's future electric vehicles. This partnership is critical because it combines Toyota's automotive expertise and manufacturing capabilities with Idemitsu's advanced materials science knowledge. Idemitsu has already made major announcements about their commitment to this partnership. The company announced plans to build a large-scale production facility dedicated to manufacturing lithium sulfide, which is a key raw material used in solid-state batteries. Once this facility is complete, it will be capable of producing 1,000 metric tons of lithium sulfide annually. That's a massive production capacity. It signals that Idemitsu and Toyota are deadly serious about scaling solid-state battery production to industrial levels. Furthermore, Idemitsu is committed to beginning mass production of solid-state batteries in 2027. This timeline aligns perfectly with Toyota's plan to introduce solid-state battery vehicles in 2028. It's a coordinated, well-orchestrated rollout that shows how far in advance Toyota has planned this transition. This is a big deal for the automotive industry. The global EV market is projected to reach 20 million vehicles per year by 2030, double today's numbers. This growth is constrained by battery supply. Every major automaker is competing for battery cell capacity, but companies that manufacture their own advanced batteries will have massive competitive advantages. Toyota understands this. They've been the world's most profitable automaker because of their obsession with long-term thinking and operational excellence. They don't rush technology to market, but they also don't hesitate when they see an opportunity. That's exactly what we're seeing with solid-state batteries. Tesla has dominated the EV market but doesn't manufacture their own batteries. They rely on suppliers like Panasonic and LG Chem, meaning they wait for improvements decided by others. Toyota, in contrast, is developing and manufacturing their own solid-state batteries, controlling their own timeline and destiny. Volkswagen has invested in QuantumScape, which has published impressive lab results for 844 watt-hours per liter, charging from 10 to 80% in about 12 minutes. They're targeting 2027 to 2028 for mass production. Samsung SDI is building toward 900 watt-hours per liter and is already supplying semi-solid cells to BMW and Hyundai, also targeting 2027. Chinese battery manufacturer CATL, which controls 40% of the global EV battery market, has taken a more cautious stance. Their chairman stated that solid-state technology is only at level 4 of 9 in development. CATL expects semi-solid cells in 2026, but doesn't expect full solid-state mass production until closer to 2030. This makes Toyota's aggressive timeline all the more impressive. Let's talk about the actual engineering challenges that companies like Toyota have had to overcome to make solid-state batteries viable. The first major challenge is stability. Solid electrolytes need to be chemically stable, thermally stable, and mechanically stable. They need to withstand thousands of charge and discharge cycles without degrading. Early solid-state battery prototypes often failed because the solid electrolyte would crack or degrade over time. This limited cycle life and made the batteries impractical for real-world use. The second challenge is ionic conductivity. Solid electrolytes need to conduct lithium ions at rates that are comparable to liquid electrolytes. If ionic conductivity is too low, the battery can't deliver high power or charge quickly. Engineers have made tremendous progress on this challenge, discovering new ceramic and polymer compositions that exhibit excellent ionic conductivity at operating temperatures. The third challenge is interfacial resistance. Even when a solid electrolyte has excellent ionic conductivity, the interfaces between the solid electrolyte and the electrodes can create resistance that degrades performance. Managing these interfaces is like molecular level engineering. Researchers have to carefully control the composition and structure of these interfaces to minimize resistance while maintaining mechanical stability. The fourth challenge is dendrite formation. In traditional lithium-ion batteries, lithium ions move between electrodes and can sometimes form needle-like structures called dendrites. These dendrites can pierce the separator and cause short circuits. Solid electrolytes are actually much better at preventing dendrite formation because they're mechanically rigid. However, managing this at the electrode-electrolyte interfaces is still a complex engineering challenge. They've tested these batteries in various conditions and climates. They've learned what works and what doesn't work. They've built prototype vehicles and tested them extensively. And now they're ready to transition from laboratory prototypes to production vehicles. One key factor that makes Toyota confident they can pull this off is that they've developed battery manufacturing expertise over many years through their partnerships and hybrid vehicle production. While Toyota doesn't manufacture every battery cell they use, they have deep knowledge of battery manufacturing processes and supply chain management. This knowledge will be invaluable as Idemitsu and Toyota work together to scale solid-state battery production to meet global demand. The partnership with Idemitsu specifically brings chemistry and materials science expertise that complements Toyota's manufacturing and automotive engineering knowledge. Let's also discuss the economic implications of solid-state batteries. The current cost of lithium-ion battery packs is around $100 to $120 per kilowatt hour. This cost has declined dramatically over the past decade, and the trend continues. However, solid-state batteries are initially expected to be more expensive because the manufacturing processes are new and production volumes are low. Experts estimate that initial solid-state batteries might cost $150 to $180 per kilowatt hour. However, this cost premium is expected to narrow significantly as production volumes increase and manufacturing processes improve. By the mid-2030s, analysts expect solid-state battery costs to fall below $100 per kilowatt hour, potentially even reaching $80 per kilowatt hour in high-volume production. At those price points, electric vehicles with solid-state batteries will be cost competitive with gasoline vehicles, even before accounting for fuel and maintenance savings. This is crucial because cost parity is one of the key factors that will drive mass adoption of electric vehicles. Many consumers care about total cost of ownership. If an electric car costs more upfront but saves money over the lifetime of the vehicle, many people will choose the electric option. But if the purchase price is significantly higher, many people will stick with what they know. Gasoline cars. This purchasing decision is fundamental to how the market transitions away from internal combustion engines. Solid-state batteries will fundamentally change this calculation. Combined with improved manufacturing efficiency and the economies of scale that come from high production volumes, solid-state battery electric vehicles will likely be cheaper to manufacture than comparable gasoline vehicles within the next 5 to 10 years. Toyota's position in this transition is particularly interesting because the company has a foot in multiple camps. Toyota is the world's leading manufacturer of hybrid vehicles. The company is also committed to a balanced approach to electrification, producing both battery electric vehicles and hydrogen fuel cell vehicles. This diversified strategy makes sense because Toyota, as a global company, needs to serve markets with different infrastructure and different consumer preferences. However, once solid-state batteries achieve the range and charging capabilities that Toyota is targeting, battery electric vehicles will become the dominant powertrain technology. Hydrogen fuel cells will likely remain a niche product for specific applications, particularly heavy-duty trucking and commercial vehicles. But for passenger cars, solid-state battery electric vehicles are going to be the future. And Toyota is positioning itself to be a leader in that future. Now, let's address the elephant in the room. The promises we've heard about solid-state batteries before and how they haven't materialized. It's fair to be skeptical. Companies have been promising revolutionary battery technology for years, and the timeline always seems to slip. Now, what makes this time different? What makes Toyota's promises more credible than the promises we've heard before? Several factors suggest Toyota really will deliver this time. First, Toyota has the manufacturing expertise and capital resources to invest in the production infrastructure required for solid-state batteries. This isn't a startup with one good idea and no way to manufacture at scale. This is the world's most profitable automaker with decades of battery manufacturing experience through their hybrid vehicle production. Second, Toyota has set realistic timelines and held firm to them. The company received formal production approval in Japan in October 2025 for their solid-state battery program. This government approval is significant because it signals that Japanese government agencies have reviewed Toyota's technology roadmap and believe the company is capable of delivering on its promises. Executive Keiji Kaida recently confirmed that Toyota is sticking to the schedule for a first solid-state EV by 2028. When Toyota commits to a timeline and gets government approval, you can take it to the bank. This company doesn't miss self-imposed deadlines for products this important. Toyota's reputation depends on delivering quality and meeting commitments. Third, Toyota has created powerful partnerships with suppliers like Idemitsu Kosen, who have already begun building production capacity. The fact that Idemitsu is investing in large-scale manufacturing facilities for solid electrolyte raw materials demonstrates that these companies are not just talking about solid-state batteries, they're actually building them. Finally, Toyota has proven over its entire history that it delivers on long-term strategic commitments. When Toyota decided to invest in hybrid technology 30 years ago, everyone thought the company was crazy. Gasoline cars were what people wanted. Hybrids were an expensive niche product that most analysts didn't believe would ever gain traction. Environmental advocates wanted electric vehicles, not gas-electric hybrids. But Toyota had a different vision. The company kept investing and improving. Engineers worked tirelessly to refine hybrid technology. The company expanded its hybrid lineup across different vehicle segments. And now, Toyota controls roughly 50% of the hybrid vehicle market worldwide. Toyota's hybrid dominance was built on consistency, quality, and a willingness to invest for the long term without expecting immediate financial returns. If you're in the market for an electric vehicle now, you have excellent options from Tesla, Volkswagen, BMW, Hyundai, and Ford. However, if you can wait until 2027 or 2028, Toyota's solid-state battery vehicles will represent a generational leap. You'll get 745 miles of range, charge in about 10 minutes, enjoy a 15-year battery lifespan, and pay a competitive total cost of ownership. For families driving long-distance highway trips, solid-state battery vehicles will be game-changing. For cold climate residents where range degrades, increased energy density means less impact. For commercial fleets needing quick turnaround times, solid-state batteries enable electric vehicles to compete directly with diesel and gasoline vehicles on total cost of ownership. Solid-state batteries will accelerate the transition away from internal combustion engines and compress the timeline for electric vehicle dominance. Industry analysts forecast electric vehicles will represent 50% of new car sales globally in the mid-2030s. With solid-state batteries arriving in 2027 and 2028, that timeline could shift forward by several years. This will pressure companies that haven't invested adequately in EV technology and reward companies like Toyota that have steadily invested in battery technology. Raw materials like lithium, cobalt, and nickel are critical for battery production. Solid-state batteries require different materials and sourcing patterns. Companies securing supply chains for these materials now will have significant advantages. Let's also consider the competitive dynamics among automakers as solid-state batteries enter production. Toyota's first-mover advantage will be substantial. By getting solid-state battery vehicles to market in 2028, before most competitors, Toyota will establish brand leadership in what is essentially a new category of electric vehicles. Consumers who want the best-in-class range and charging speed will have no choice but to look at Toyota and Lexus models. This will allow Toyota to command premium pricing in the initial years of production. As production volumes increase and supply chain costs decrease, those premiums will compress, but by then, Toyota will have established a reputation for building the best solid-state battery vehicles. That reputation will be valuable as the market matures. Furthermore, Toyota's experience with hybrid vehicles shows how a company can maintain premium pricing even as the market grows and technology becomes more widespread. Hybrid technology is now commonplace, and dozens of manufacturers offer hybrid vehicles. Yet, Toyota hybrid vehicles still command a price premium over comparable gasoline vehicles because consumers perceive them as better quality, more reliable, and offering superior real-world performance. Toyota's hybrid reputation has been built through decades of consistent quality and customer satisfaction. The same dynamic will likely apply to solid-state battery vehicles, particularly coming from Toyota. Consumers trust Toyota to deliver on advanced technology promises because the company has repeatedly done so in the past. Now, let's look at the specific vehicles that Toyota is expected to bring to market first. As mentioned, Lexus models are likely to receive solid-state batteries ahead of mainstream Toyota brands. Lexus currently offers the RZ, a mid-size electric SUV that's been well received by luxury buyers. This is likely to be among the first vehicles to receive solid-state batteries, probably arriving in 2028 or 2029. The Lexus RZ will become an entirely different proposition with 745-mile range and 10-minute charging capability. Imagine having an electric luxury SUV that can travel nearly 800 miles on a single charge and charge to full in less than 30 minutes. It will become one of the most capable electric vehicles on the planet. Toyota is also expected to introduce a next-generation BEV, or battery electric vehicle, sometime around the same period. This vehicle might be a successor to the current BZ4X electric SUV, but with significantly enhanced capabilities. With solid-state batteries, a next-generation BEV from Toyota would immediately become competitive with or superior to existing electric vehicles from Tesla, Volkswagen, and other manufacturers. Toyota's engineering and quality reputation combined with solid-state battery technology would be a formidable combination in the marketplace. The exact specifications of these vehicles remain to be announced. Toyota has been characteristically quiet about specific models and features, which is typical of the company's approach to new product launches. The company keeps detailed engineering specifications and design choices close to the vest until just before launch. This strategy builds anticipation while also preventing competitors from understanding exactly how Toyota has solved specific engineering challenges. The company will likely begin sharing details as we approach the 2027 and 2028 launch windows. Expect official announcements about specific models, features, pricing, and availability sometime in 2026 or 2027. Initially, solid-state battery production will be limited as Toyota works through manufacturing challenges and ramps capacity. This allows the company to maintain pricing power and focus on quality. By the early 2030s, solid-state batteries should appear across multiple Toyota and Lexus models. By 2040, solid-state technology will likely be standard for all Toyota electric vehicles. This transition represents one of the most significant technological shifts in the history of transportation. For the past decade, the conversation about electric vehicles has centered on whether they can be as convenient as gasoline cars. With solid-state batteries, that question becomes irrelevant. Solid-state battery electric vehicles will be more convenient than gasoline cars in almost every way. They'll have greater range, they'll charge faster, they'll require less maintenance, they'll be cheaper to fuel, and they'll produce zero emissions during operation. The era of gasoline vehicles is coming to an end. That transition is already underway. But when solid-state batteries hit production vehicles, that transition will accelerate dramatically. And Toyota, through decades of patient investment and strategic partnerships, is positioning itself to be the leader in this new era. For consumers, for the environment, and for the future of transportation, solid-state batteries represent exactly the kind of breakthrough technology that we need. They represent the culmination of decades of research and investment. They represent a partnership between automotive companies and materials science experts. And they represent the confidence that technology can solve the challenges we face. Toyota's commitment to solid-state batteries is an affirmation that the company believes in the future of electric transportation. It's a bet that consumers will embrace electric vehicles once they offer the range, charging speed, and convenience that solid-state batteries will deliver. And based on everything we know about Toyota's track record and commitment to excellence, that's a bet you can take to the bank. The solid-state battery revolution isn't coming someday far in the future. It's coming in 2027 and 2028, when the first production vehicles roll off assembly lines with this transformational technology. And when that happens, the automotive world will never be the same.